best. You can be the King Kong banging on your chest.
Sure gang, welcome back to my YouTube channel. And of course, I am the one and only Karabo Sithole. So in today's video, we are going to be doing part B of our previous video, in which we talked about the tips that you need to know for your time series segment of test 2, right? So in today's video, we're doing probability. So the things that I need you to know before you get into that exam are the following. But before we get to that, if you have not yet subscribed to my YouTube channel, make sure you click that subscribe button. Okay, we'll wait for you. Okay, thank you. Let's get right into it, right? Okay, so what should you know when you're doing probability, right? This is for, I'm sure you've gone through the content, so I'm just giving you the key points here. You should know your content. You should have done the past papers. I'll be releasing videos from tomorrow onwards. I think at least 2 past papers. Say is also going to be doing revision, so attend that revision session, because I'm going to be doing past papers that were not discussed in the revision session, right? So let's get right into it. So I already wrote notes, so I'm just going to be going over what I wrote. So the first thing that I want you to know is, how do we represent likelihood, right? So remember that probability is about how likely is something going to occur, right? So how do we represent this likelihood is the question, right? First of all, we represent it in notation way. Probability of A, when they write probability of A, and they tell you what it is, probability of B. This is what we call notation, right? But in all the notations that we had, the one that stood out the most for me is the one with this long line called a complement, right? It's the sign of complement. So what is it? One thing I want you guys not to fall for, which I know will be in the test, is that this is not, it is not equal to the probability of not A and the probability of not B. This is very wrong. This is wrong. So first things first, I want you guys to understand that this is wrong, and they are going to try to trick you, and do not fall into their trap. So it's not equal to that. We'll get to what it is equal to. Another one that stood out for me is the one where this sign, the union, where you have a union instead of an and, right? So I want you guys to understand how we separate this line into these 2 lines that we can work with. And for this, we use what we call the Morgan's rule. So I'm going to discuss the 3 rules that you need to know, but I'm going to link it to these 2, right? So the 3 rules that you need to know is the Morgan's rule, which helps us to separate this whole line into these small lines. Addition rule, which is very important, right? And the intersection rule. So our main focus in test 2 is probably going to be your Morgan's rule and the addition rule, but don't forget about your intersection rule. It might help you. In all the past papers I did, it did not help me. The ones that helped me were the Morgan's rule and the addition rule, as well as other things I'm going to be discussing, right? So how do you use the Morgan's rule to separate this whole line into the small things? So the Morgan's rule directly from your formula sheet says, in order to separate this whole line into small bits, right, into these small lines, you need to switch this thing. You need to switch this. So since this is an and, it means it needs to become an or. So I'm going to have the probability of not A, right? Because it's an and, it needs to be an or. Probability of not B, right? So there you go. Don't fall for this. This is what this is according to Morgan's rule, right? And then this one, the rule stays the same. If you want to change this whole long thing into something that has small bits into it, you swap the sign, you swap the union sign into an and. So this is going to be equal to the probability of not A and not B. So there you go. There we are. And that's the Morgan's rule, right? What I just wrote here. The addition rule says the probability of A plus the probability of B less the probability of A and B will be equal to your union, right? Cool. So that's the first thing that I want you guys to understand. Make sure you crack it. Make sure you understand, like, make sure that if someone asks you in your sleep what the Morgan's rule is, you can actually tell that person, right? Okay, let's get to the second thing that I want you to know. I want you to know how to use the contingency table, how to write it using this given information, right? Using the given information, and I want you to know how to interpret it, right? So let's do that quickly. So in this example that I have, you have that the probability of A is equal to 0.7. They said the probability of A. So it's the whole A, right? Not A and B, not A and not B. They said the whole A. So you take the A and you take it to the total, 0.7, right? They told you that the probability of B, right? The whole of B. So B, everything that is B, it's what? 0.345. Another thing that I want you guys to understand with the contingency table is that if you are working with probabilities, it is always going to be equal to a 1, right? So you have a 1 here. Okay, there's another concept that the contingency table shows well, right? There are also other concepts such as partitioning that it shows well, but specifically it shows well the concept of complements, right? When something is a complement of another, right? So we say not A, just like here. So the complement of one event is 1 minus that event. So the probability of not A or the complement of A is going to be 1 minus 0.7, which is going to be 0.3. So at not A, I need to put 0.3, right? Easy, right? Probability of not B, which is the complement of B, is going to be 1 minus 0.345. 1 minus 0.345. 0.655, right? So not B is going to be 0.655. You are also given something else. You are told that the probability of A and not B. So A, right? But not A and B. However, A and not B. So I'm here, 0.4. Right? Now that I have used all the information that they gave me, I now need to use my mental, my addition skills, right, from primary school. If the total is 0.7 and you are adding B and not B to get to 0.7, how do you get B? 0.7 minus 0.4. Right? And that is 0.3. Right? What else? Now I have this, right? So to get this, I added this and this. So how do I get this? It's this subtracting this. So 0.345 less 0.3. This is 0.045, right? Now I have two things, so I can work what's inside or can work either way. So it's going to be 0.3 less this, which is going to be 0.255. Right? So that is how you draw the contingency table. Do you guys get it? Hope you do. So how do you interpret the contingency table? So you are going to use the contingency table on questions like this one that I'm about to show you just now. Forgive what is written here, right? Because my book needs to be dirty, right? So whenever you are given something like this, right? So these are your options. The options that you need to choose from, right? You're given all these things that look complicated. Always draw a contingency table if there is something like this. It helps you answer the question. Because how are you going to know this if you don't draw the contingency table? Are you going to use the multiplication rule? Okay, you can go ahead and try it. It's only part 1 probability. I mean, there's nothing wrong with it. So just do the easiest things for now and get a distinction in test 2. Test 3, you'll get a chance to use the multiplication rule in test 3, right? For test 2, make sure you know how to use the contingency table. Cool. So how do we interpret it? So if they had to ask you for the probability of A and not B, A and not B, 0.4. Not A, not B, so not A and not B. So the probability of not A and not B, right? So it would be 0.255, right? So that is how you use a contingency table. Okay. Just want to make sure you guys can see what I'm writing. Okay, cool. Let's go on to the next thing that I want you guys to understand. Remember, we're still looking at the 3 ways of representing likelihood. We said, first of all, notation. Secondly, contingency table. The next thing is your are your tree diagrams, right? Representing your information on a tree diagram, right? So for example, you're going to use it on an example like the one I'm about to use, right? Rolling a 6-sided die and tossing a coin. So you're looking at the likelihoods, the outcomes that you can have. So when you're rolling a die, you can have a 1, a 2, a 3, a 4, a 5, and a 6, right? So 1, 2, 3, 4, 5, 6, right? When you're tossing a coin, 1, you can have a head, a tail, head, tail, head, tail, head, tail, head, tail, head, tail. So if they had to ask you the number of outcomes that you're going to have, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 outcomes. Another way to get to the number of outcomes that are possible is for you guys to remember your counting principles from grade 12, right? So the likelihood, when you're looking at the number of outcomes, how many outfits can I make when I have 6 t-shirts and 2 trousers, right? It's going to be the likelihood of each multiplied by each other. So in this case, looking at a die and a coin. What is, like, how many outcomes can I have here? 6, right? So it's going to be 6 times how many outcomes can I have of the coin, a head and a tail? So 2, right? Which gives you 12 outcomes. Okay, so that's the tree diagram for you. Nothing hectic for now. Yes, because you don't have dependent events. Nothing hectic for now, just this, right? So the main rule that I want you guys to remember in test 2, when for some reason you find a question that requires you to do a time diagram, is that when you go across, you multiply. So when I go across, I multiply. If this is a fair die, this is going to be 1 over 6 and 0.5, right? Going across, I multiply. Going down, I add. So for example, if I was looking for H1, it would be 1 over 6 times 0.5, right? T1 would be 1 over 6 times 0.5. If I want the probability of this or this, I will add this and this because I'm going down. Going down, we add. Going across, we multiply. So this is the general rule that I want you guys to understand when it comes to tree diagrams. Cool. Hopefully you guys are liking this video and you are understanding. Please make sure that you comment, you like, and you subscribe. Please share as well so that it helps somebody else. Just want to make sure that you can see what I wrote. Okay, you can. Okay, next thing is, what is the difference between partitioning as well as your overlaps, right? When something is partitioning, it means that there's no intersection between the two events. It means they are not meeting. They are just sharing the sample space, right? They are sharing the full sample space, another thing, right? Whereas with overlaps, they are intersecting. There's an intersection between the two events. Here's the intersection. Partitioning, event A and B are sharing the sample space, and they are exhausting the sample space. They are taking up the full one, right? When we're looking at probability, because the probability of the sample space, remember I'm emphasizing this, the probability of the sample space is 1, right? So they are exhaustive. To be exhaustive means you are filling up the full sample space. They are filling up this whole triangle here, right? Overlap is just when they are touching, when they are intersecting. We can also have, okay, this is another sample space, ne? You can have a full overlap. This is a partial overlap. A full overlap is when the other circle is inside the other, right? Okay, so let's look at our contingency table. This is why I love the contingency table, because from it you can like answer the questions where you have intersections and whatnot, but you can also answer your, sorry, I ran out of space, so I think I ended by saying something, so I'm just gonna say end your partitioning, right? So I'm going to like show you how to use the contingency table, how to do partitioning using a contingency table. So what I want you to do is to read, right? It says event A and event not A. So you will shade event A. This is the whole of event A and the whole of event not A, right? So as you can see from here, it's actually partitioning because it's not intersecting first of all, and it's exhaustive, meaning that when I add this, and this, it should give me a 1, right? So that's what partitioning is. There are two rules. It needs to be mutually exclusive, and it also needs to be exhaustive, right? So once it starts intersecting, we cannot say it's partitioning, because partitioning means that it's distributing the sample space between the events, but without the events actually intersecting, right? Let's look at event B. So in the exam, just make sure when you draw, it's not, you don't draw too hard, right? So that you can erase. Okay, so event B, this is event B, right? So you'll draw event B, and it says event A. This is the whole of event A. So if you guys can see from this, it's actually intersecting at A and B, right? So it cannot be partitioning, and it's also not exhaustive because this is not included, right? So not partitioning at all. So the main rules are that for partitioning, it needs to be mutually exclusive and it needs to be exhaustive, meaning that when I add the probabilities, I actually get a 1, right? So yes, that's just that. So another thing that I want is, the last thing that I want you to know before you get into that exam room, test room, your maximum and minimums, right? So I have an example here. It says that suppose two events A and B exist such that the probability of A is equal to 0.45 and the probability of B is equal to 0.32, right? So you want to approximate the maximum and the minimum, right? So you want to approximate these using your minimum and maximum, and this is because you are given partial information, right? So first step that I would do when I'm in that exam room is check this sign. Is it a union or is it an intersection? Because the rules are not the same depending on whether it's a union or an intersection, right? And then the second step, regardless of the sign, is that you should add the probabilities, right? So for example, in this instance, we are talking about not A. So I'm not going to add A, I'm going to add not A. So now I need to find what not A is. Not A means probability of not A is equal to 1 minus the probability of A. So the probability of not A is equal to 1 minus 0.45, 0.55, right? Okay, so we add them. So step 1, we check the sign is a union. So the union rules are going to apply. I'm going to show you the union rules. So 0.55 plus B 0.32 gives me 0.87. So if you guys see, this amount is between 0 and 1, right? Meaning that there's a possibility that it is mutually exclusive. So whenever your amount is between 0 and 1, there's a possibility that it is mutually exclusive. So you will have your options mutually exclusive, you will have your partial overlap, and you will have your full overlap. So your partial overlap will be something like this, your full overlap will be this. Okay, so whenever your answer is between 0 and 1, mutually exclusive, you give it a tick. This one, you give it a no. Because remember the addition rule, it says the probability of A plus the probability of B less the probability of A and B. And the reason why we are subtracting this is so that we don't double count. If we don't subtract this and we add this and this, it's going to give us an answer that is greater than 1. But probability can only be between 0 and 1. So because in order to like approximate, we don't consider this part so that we can see if there's an intersection or not. So if we add probability of A and probability of B, and if there's a partial overlap, it means that we have to double count, meaning that we need to get an answer that is greater than 1, right? However, if our answer is not greater than 1, it means that there's no way you could see it's partially overlapping, right? So this one is out, then you take the other one. So for the union, remember it's 0.87, right? So for the union with your overlap, remember union is adding the events, right? So obviously the smallest one is going to be the one inside, the one outside is going to be 0.55, because think about it, the smallest one has to have the smallest probability, the one outside has to have the biggest probability. That makes sense, common sense, right? So if you think about it, really, union means that I'm adding the two events. So which probability is likely which probability is it likely to take? It's going to be the bigger one because I'm adding what's inside and what is outside, 0.55. So whenever it's a union, you always take the biggest probability. That you need to know. Whenever it is a union, that's why I said check the sign first. You always take the biggest probability of the events that you are concerned with, not just any event, the events of not A and the other in the B1. Biggest probability of the events you are concerned with. This is very important. If this was an AND, right? So I add both of them, but because it's like less than 1, that means this one is out, so I have this one and this one. But remember, I'm checking if there's a possibility that it is mutually exclusive, and then I tick. So if there's a possibility that it's mutually exclusive, what is the intersection of mutually exclusive events? From this, there's no intersection, meaning that my minimum is going to be 0 and my maximum is going to be what is inside, because the end, remember with the partial overlap, the end was the smallest thing we had here, which is what we have of A and what we have of B, right? So the intersection makes sense for the intersection to be the smallest probability. So another thing to take note of is that you have a 0 for the mutually exclusive, as well as that the smallest probability. So this is for this, right? And this is for this. Smallest probability for end, right? This is for end. So let's just say our answer was not 0.87, it was greater than 1. For the or, it was going to be the 1 minus whatever the answer was. Let's just say it was 1.05, right? So your end is going to be the intersection, which is 1 minus, 1.05 minus 1, which is 0.05, right? That was going to be your intersection. In terms of the or, it was going to be 1. It's always 1. It's a row. It's always 1 here. And then you will take the other one, right? If it's an or, it means that you'll take the biggest probability and you'll take a 1 from the partial overlap. So if you did not get that, please rewind, right? Go back. I'm not sure if it's called rewinding, but just go back to what I just explained. Play it on the lowest speed possible so that you understand. So thank you so much for watching my video. Thank you so much for subscribing. See you guys in the next video. Hopefully this helps. So in the next video, we are going to be doing our test videos, right? So I'm going to be doing 2 tests, as I said in the previous video, that I'm going to be doing tests that were not done in the tutorials. So bye guys.